Thank you. I'm not sure how this is going to work when I get to the live coding part, so maybe one-handed. This could be a growth journey. Yeah, sure. So quick introduction. I'm Daniel Grant. I'm actually just visiting San Francisco this month. I've been here through February. I'm going back to Scotland tomorrow, so this is my farewell. Thanks for this beautiful dinner and seeing me off. As you can tell, I don't have a Scottish accent. I grew up in England. I have two Scottish parents. That makes me kind of Scottish. That was my after dinner joke. I thought because it was like an after dinner speech, I should do a bad joke. So there it is. And I'm talking about a project I've been working on. It's very much mid-flight, and I want to share it with you because I would like to have your feedback and share some of my learnings along the way. And I really love this about Meetup communities, is that you don't have to come with a polished thing. You can just share what you're working on and give it to the community and get something back from the community. Back in Glasgow, I'm an organizer of the GlasgowJS Meetup. And so I really love that about that community, that we kind of share and encourage each other. One thing I've learned, speaking to a lot of software developers over the last year and doing a lot of interviews, is this is my key insight. The pattern I've spotted is everyone's just a bit insecure. Like, we're all just looking for some validation. And I think that's where these communities play such a vital role, because, you know, we're out there pushing our products out in the world and in this sort of super hyper capitalistic environment, and like trying to get ahead, and we're all looking for validation. So there's like a marketplace of people looking for validation, and there's not much going around. And actually, like, we all have the capacity to give validation, and it's free. You know, you can just sign as many validation checks. And I think as you grow as a developer, it's really important just to make sure that you just give some encouragement to people who are coming up on the journey. I feel like an imposter all the time. I don't think it's imposter syndrome. I think genuinely I am punching above my weight a lot of the time, and I love it. And I think everyone who does that, you know, hats off to you, because, you know, that's what a growth mindset's about. So that's my little spiel about community, and just to say I'm really happy to be here in this community, and thanks for having me as a guest. So talking about JS native development for cloud native deployment, which I can summarize as my love-hate relationship with the cloud. So this story begins for me in 2020. If you come with me back to lockdowns, I'm in my living room cupboard, which I've converted into an office, and a friend of mine wants to start a startup. He has an idea. We can make some money by getting a lot of data, analyzing that data in a really smart way, doing it very quickly, and optimizing some ad campaigns. And so I thought, great, I love a project, and I will go to my trusty indie Node.js stack, which was Node.js, Postgres, and sorry, Praveen, PostGraphile, which was a great stack. And it looked a bit like this, just like a bunch of services running on a DigitalOcean droplet. And I think spending $5 a month when we started this. I even had the Postgres database in there. As this grew, obviously took the Postgres database out somewhere else, and I bought a bigger droplet. And then we got some customers, and we were starting to process millions of rows of data every day. And then we signed up for more customers, and I scaled up to a bigger EC2 instance. And then we got some more customers, and my trusty indie stack just kind of blew up. And at that point, I thought, all right, I need to horizontally scale this. So I had this vision, all the functionality that was in this single process, rather than me increasing the RAM and the CPU, I would horizontally distribute it. And I'd heard of such tales of horizontal scaling. I thought, how difficult can this be? So I had a little look around, and thought, what's the sort of typical serverless architecture? I was in for a whole lot of finding out. This is a typical serverless architecture. And to my mind, that's kind of complex. And I think this is something I contended with for a while. At first, I thought perhaps I'm just not smart enough for this, and then I decided I am smart enough. It's just not my personality type. This feels more like the sort of thing in another life I might be like an accountant or a lawyer or a civil servant, and I'd love bureaucracy. But I'm not in that life. I'm in this one, and I like coding and like pushing things to production and getting tactile feedback and breaking stuff. And here I had this new way of working where I had to look at UML diagrams, and that was quite depressing. And then I found the documentation, and verbose is really the description for it. There was a lot of bureaucracy. So let's have a look at some of the tools that help with building serverless applications. Now, I'm going to share some of what I've been working on, but you know, it's a project that you're not going to use in production today. So I want to do a little tour of some of the other ones out there, because there's some great projects out there, and we should let's see how I get on with one hand. Okay. So, not that one. Here we go. Serverless examples. So the first port of call, I think, is serverless framework. It's named after the technology, so that seems like a good place to start. It all begins with serverless framework. Your serverless architecture, that diagram that we saw, is described in a YAML file. So I downloaded one of their starter demos, and I should probably bump the text size up for folk. How's that? Is that too much? Perfect. Is that okay? This is good. This is good. Okay. So there's some nice things here. I declare a provider. That's the cloud platform that I'm going to deploy to. And I can also add parameters here. For example, if I want to deploy to a particular profile, so you can have like different AWS accounts and within an organization. And then the main paradigm is that you've got serverless functions. So in this example, I've got two functions. One called rate handler, one called quant handler. I wanted to get something where I could just run a function on a schedule. So this one runs every minute, and this one runs on some quant expression. And then in my code, now we get to the JavaScript bit, we've got the function. So there's a few things that kind of correspond here, how we link these together. So this is a definition of what should get deployed to AWS. And here we have the name of the file and the name of the function after the period. I'm just giving myself a little kind of subconscious pat on the back for using period and not full stop or dot, which we would say in the UK. So well done me. And that corresponds here. Now, actually, you can see that I've got a mistake because the file name is correct, but the name of the function is wrong. I'm calling it handler here, but actually in the file it's called run. So I would need to fix this if I'm going to deploy it. So I can try actually deploying this. Let's see. So with serverless, you run the command serverless deploy. It's not that. Serverless. And that will stand up some infrastructure on AWS. Now you can see that it's using something called CloudFormation. CloudFormation is AWS's own infrastructure as code tool. So that sort of manages all the resources that gets created. And so AWS has a tool for this. The main point of showing you this this deploy is just to demonstrate that it's actually quite slow. So I've got two functions. I've got a cron job that's running effectively, and this will, I think, take over a minute to deploy. Also, it's not going to work because, as I said, the function is called run, and the infrastructure definition is pointing to handler, and I'm not getting any error reporting about that. So this was my sort of first stop on my serverless tour, and there was a few things that sort of bothered me about this. One was I'm describing kind of critical parts of my application with YAML. And actually, as it gets more complex, you start to see JSON inside the YAML, and then there's these other parts of AWS that describe, and it started to go into that sort of AWS bureaucracy thing. And I was like, I don't know if I want to write all of that in YAML. I would be much more comfortable writing that in JavaScript. Well, fortunately, there is a framework for doing this in JavaScript, and that's Pulumi. So CloudFormation is still deploying. So we'll, I think I've proved my point. It's quite slow. So let's switch over to Pulumi. So Pulumi does have some YAML files, but they're not doing anywhere near as much. With Pulumi, you've got one that basically describes the name of your project, and another one that, yeah, just saying what region you're deploying to. And then the rest is JavaScript, which is great. So let's take, again, an example. I used their AI tool to generate this. Let's take an example where we create a REST API. And what's kind of really interesting here is that I've got my serverless function, and that's in the same module as the module that's describing the infrastructure. So this section here is describing some cloud resources that are going to be created at deploy time. And this here is actually referencing runtime code that is not part of the infrastructure creation, but is actually the code that gets run in your application when it's live. So I think get date, so there's my function. And I can add some TypeScript types as well. It's not brilliantly typed. I mean, I could probably find the correct types for this, but you know, I've just sprinkled a few any's in there to get going. But yeah, that's got me running. Another thing that's really interesting about Pulumi is that you can even write this in line. So, and this is going to give me some types. It's not necessary. I could still, you know, write a function that doesn't comply with the API gateway, but you know, I can write this in line. I feel a bit weird about this, if I'm honest. I kind of would prefer to have the runtime and the infrastructure code somewhat separated. How's our serverless deploy going? It's deployed now. So there we go. What's interesting about Pulumi is, so this is, I wonder if I could show you the infrastructure that gets deployed for this. So it has a dashboard, as does serverless. Yeah, of course. Thank you. So I think I've actually not deployed that yet. So I'll show you this once it deploys. We can see the resources it creates. So let's deploy this one as well. So pretty similar to the serverless example, we run Pulumi up, and that will stand up a stack for us. It's going to ask me some questions. I'm in the wrong. Okay, I'm not gonna deploy that because I don't know why that's not doing what I want. But the point to make here is that there's a bunch of extra AW resources. So the Lambda needs an IAM role, which gives permission to the REST API to call it. And if you're not familiar with AWS, like what an IAM role, and you also need a permission to all of the routes in your API. So you have to create these permission resources as well. Now, Pulumi has sensibly abstracted that away. But one of the issues with this abstraction is that it's essentially, once you start to extend it, so here I add an authorizer and here a validator, it starts to feel like that YAML file again. There's a lot of configuration coming from the top down, and if I want to do more, it's not the usual compositional model that I'm used to. Okay, so these are amazing tools, and people have built billion-dollar companies with these tools. I'm not here to put them down. I'm here to explore them, and some of the frustrations that I found with them and what kind of motivated me to think about how could this possibly be different. I've used Pulumi in big projects, and you can do lots of great stuff with it. So, hats off to them. And also, the getting runtime code mixed with infrastructure code is some crazy compiler stuff that's going on here. I don't particularly love the idea of it, but I'm very impressed by the engineering effort there. Okay. So that was my journey into serverless. And this was my reaction. I don't want anything to do with this. This is really not how I like to develop. What I really wanted was the scale of serverless, but the speed of development that I was used to. So I wrote a wish list. I didn't really, but this was my kind of subconscious wish list. I wanted a small set of serverless resources. Now, Pulumi, Terraform, and so on support tens of thousands of resources. I don't need tens of thousands. I need EventBridge and API Gateway and Lambda and a few others. I wanted a Goldilocks abstraction. A little bit of abstraction, not too much, just the right amount. I don't want to have to deal with all this cloud wiring, IAM roles, permissions. I feel like that could be just figured out. But at the same time, I don't want to have my capabilities limited. I wanted end-to-end types. I'm using TypeScript all the time. It really frustrates me if like one part of my code base can go out of sync with another part, and I'm not going to get a compiler error. I also found that development tools for local dev, they never really reproduce production that well. So I kind of wanted just to be able to deploy straight to the cloud and develop on the cloud. It's quite hard to emulate a distributed system on a single computer. So I thought it's pretty better if I could just do local dev on the cloud. I wanted transparency. I wanted basically view source for AWS. I write some code if there's an abstraction. I want to see what that abstraction is doing. I want it to show me, like, how is it linking stuff together? And I want code that scales as well as my infrastructure does. I don't want to kind of get into like configuration hell once I start building out this application. Sure, AWS is amazing for like running stuff at big scale, but does my code base scale? Okay, how's this going? Let's do a little demo. I think I have a notation project. There we go, here's one. So I just installed this on the way here. This is the Notation. Notation is the project that I've been working on. This is what the starter kit gives you. So you'll see I've got my desire of having my infrastructure code and my runtime code separate. But as we know, infrastructure resources and runtime code are inherently coupled. So how does it help with this? So kind of similar to the Pulumi example, I can import my function into my infrastructure module. You can see as I'm hovering over it, that's got the types for it. And actually, I could probably just get the my back, command click into that. So that's great. So they're all in the same type space, which is nice. So I know that this is going to compile as one unit. Let's just mess around a bit with this. So let's say, so this is going to be a Lambda. One difference here from Pulumi is that the configuration for the Lambda is declared within the Lambda function. I think that's useful if you're using the same Lambda in a few places. Generally, the place where you would think about like how much RAM do I need in this Lambda, when should it time out, is probably alongside the code. So that lives alongside. The method that I export here is the Lambda function that's going to get executed. And that can handle various different events. So here it's handling an API request, but I can change that. So I don't know, let's take an SQS event instead. That breaks the types on the Lambda itself, because an SQS event shouldn't return anything. But it's also broken my API, which is now complaining that it was expecting an API gateway handler, but it got an SQS handler. So cool, I've got like very quick feedback on changes on my runtime code that break my infrastructure code. So let's just fix that and just see if we can deploy this. So similar to both serverless framework and Pulumi, I can do npm deploy. This is notation deploy. And so that's going to stand up a stack for us. Now, actually, while that's going, I'm going to get another terminal window and run a dashboard. See if my one-handed type. Oh man, the deployment was quicker than I could type that command. That's annoying. It's good that it was quick. So yeah, this is the infrastructure resources that is stood up. You can see that for the Lambda, there's actually like a bunch of this kind of like wiring that you have. Actually, pretty better if I show you this with a visualization. So I can run the npm run. Now I haven't built this into a dashboard at this stage. I'm just sending an encoded string into Mermaid's dashboard, so they're doing it for me. But yeah, this is from really kind of just this is why AWS is so complicated. It's like there's so many components that are needed to kind of piece things together. So here we're just declaring two resources, an API or three, an API, a route for that API, and the Lambda function itself. And you can see that there's quite a lot of infrastructure resources that are needed to make that work. Like the API gateway needs a stage, and we need a permission, and you obviously want logging as well. So we had those two. If I switch back to the dashboard, yeah, I mean, dashboards, I'm not like super into having loads of dashboards, but one thing I really wanted was if I stand up some infrastructure, I want to be able to like just quickly click through into the AWS console. It can be quite overwhelming, especially for a beginner, finding all your resources in AWS. And so just having a quick link into that was like on my wish list, and also having like the key outputs. So here we created an API. So this is the URL for that API. Now it's not found, and you can see the reason it's not found is because this API route is on the index. We're looking at the index route on the URL, and this route is on to-dos. So I can change this so it's on the route that we're looking at. But actually, it's kind of a bit annoying, like deploy, redeploy, deploy, redeploy. So can I get that desired local development workflow? So let's do npm run watch. So in the development of this, I decided not to build on top of an existing infrastructure as code provider and just like build that from scratch, which is really, really daft idea. Yeah, sensible laughs from the audience. But it has given me some like abilities to like innovate on what you can do with deployment. So actually, if I save this file, if I save this now with this new route, you see that it immediately picked up that change, and it's already created the new route and it's destroyed the old one. So now if I go back to the browser, that's redeployed that. Now, just to draw this out, this point a bit, serverless framework will allow you to kind of redeploy a function. STT is another kind of similar to serverless framework. It will do live reload to a function. This is actually doing hot reloading of infrastructure resources. So, you could do it with EventBridge or CloudWatch or whatever, and it will like, remove any old ones and stand up any new ones. So I think that's probably as much demo as I need to do on that. Can I show you just I think I've got a bit of time. Show you sort of like a feature I'm working on as I'm sort of exploring this space. So far I feel like this is a nicer development experience. I like that I'm not passing like one big object to my router, that I can just compose new routes, similar to how I do with Express. I can add auth, but anyway, let's go to code that is totally not real at the moment, but great to get feedback before I actually have to write some compiler code. So one of the things we think about, like, how do you get infrastructure resources into your serverless functions? Let's say I want my serverless function to write to a DynamoDB table that I've created in the infrastructure. What would be a nice pattern for doing that? Now, Pulumi, this is where you see Pulumi stops being quite so nice an abstraction. Once you get out sort of the supported crosswalk resources, then you're really back into like just interfacing with AWS in the sort of AWS way. I've never understood why I would need to put an arbitrary date from 2012 into a policy document. It's like, why do I need to know the 17th of October 2012? That's an important date if you're working with AWS. So actually, Jason and I were just chatting earlier about how, really it's like a lot of this feels like something that a compiler should do. Like a lot of this is just like it's implementation detail of the cloud platform. Can we not just compile this stuff? So bit of a mess here, but what's kind of cool with Pulumi is if I create a DynamoDB table here, I can actually import that Dynamo table in a function, and I can use the outputs of that infrastructure resource to then, use like write to a Dynamo table or to instantiate a Dynamo client or whatever it is, RDS, SQL, whatever you're using. So I'm kind of playing around with this pattern, and here I've got an event bridge. So event bridge can run code on a schedule. So, just a event bridge schedule that calls a function every minute. I also have another module, which is my DynamoDB table. And then in my function code, I'm importing that Dynamo table. Now, the way I've been thinking about this is, how do you safely cross this boundary? So it's really not safe to run runtime code in your infrastructure state. You really do not want to accidentally run the code that sends off the alert from the president that everyone needs to go into their bunkers, if that's a serverless function somewhere in the US government. So it's super important that runtime code does not work. But if I'm bringing infrastructure resources into this runtime code, I need a way for the compiler to be able to recognize that and run some code. So we need some boundaries. And so I've been thinking about using macros, which here are prefixed with a $sign. And that can then be run at compile time. And it's essentially anything inside the macro can be safely run in the deployment stage, in the infrastructure compile. And so here, again, alongside the Lambda rather than outside the Lambda, I'm saying this Lambda requires a policy, which is to say you're giving it some permissions, and the policy is to be able to put an item on the DynamoDB table. Now, I think this could be taken to another level, depending on how much abstraction you want. Perhaps rather instead of saying we're going to attach a policy to the Lambda, we could actually import a macro which returns a DynamoDB client. And so with this one, in my client, I say what methods are allowed. And if I was to say to change that to just get item, thank you, Copilot, for that. Now my put item method on the client is giving me a type error. And I think that's quite handy, saying at the top level, these are the permissions that we're granting to this client. And if I try to do something else, I'm going to get a type error rather than having to go and collect that bug in production. Quick plug for our sponsor, Sentry. If you're not using Notation, you can use Sentry to find those runtime errors and fix them that way. So that's Notation. That's how it's going. I'd love to, chat with you afterwards and hear your thoughts. Thanks. Please connect. LinkedIn, Twitter, the GitHub repo is on there. My email address, my calendar, if you want to book a video call with me. I mean, I'm just free access to everyone and everyone on the internet who's watching this as well. I might remove that URL once you publish this, Christian. But yeah, thanks so much. It's been lovely to be here. And do we do Q&A? Is that? Yeah, I don't mind. Thanks.
Thanks. So way back in the day, I used to use JS, which would basically take an Express server and deploy it to serverless. I forget exactly how it works, but I remember that like one advantage of that is like you just write your like server code and you can run it on your server as a normal server, and you know, it makes it easy to test. Tell me what the advantage of using notation is versus something like Claudia.
I'm gonna knock your question up a level to what's the advantage of like using serverless for an API versus using, say, Express. Yeah, yeah. I think I think you're limited actually with serverless on AWS to only 100 routes per router. So if you are doing like a big API, you probably are better running Express inside a serverless function. So yeah, for like a big API, that probably makes sense. I think the advantage of serverless is sort of the simplicity and the guarantees. A lot of what serverless is about is like taking risk and turning it into a guarantee. So there's a risk that I write my code wrong and that's not going to be a API route, or there's some error or something. Or, you know, there's a risk that if I've got a server running, it's going to run out of memory and then it's going to take everything down with it. And so I think the principle of serverless is like take those risks, turn them into guarantees that can be represented as infrastructure resources. The advantage of notation is that you get a contract with those guarantees, which is types. So types become like a contract to the guarantee. But I think in that use case, like, I mean, I really wouldn't actually encourage anyone to use serverless unless they've got to that point I got to, where it's just not making sense to just keep running on a single process. I hope to, you know, I hope that whether it's notation or something else, we exist in a version of the world where serverless is as productive, but right now we're not in that world. So just keep using Express.
I saw you kind of showed like the AWS docs, and I think we all kind of have that feeling when you open up AWS and you're like, holy shit. Like someone wrote a Harry Potter series for me to deploy my server that I was just deploying. I was wondering if you saw Kubernetes, because I feel like Kubernetes is already kind of an abstraction on top of a lot of this stuff, but it's kind of an extendable abstraction. So like if I wanted to make my own cloud service, like if I wanted to make my own Amazon DynamoDB, like Kubernetes would kind of allow me to do that. Whereas like if I wanted to make some new cloud abstraction, like I'd have to wait for you to support it. So I'm just wondering like, if you looked at Kubernetes and decided that was also like reading a novel and this is not, or just what the difference was between this and kind of just like raw dogging Kubernetes.
I don't have any real world experience using Kubernetes other than being on the other side of a platform team that is providing it as a service. So I can't really opine about like it. I think it's a nice concept, you know, like you declare the state that you want, it does it for you. What I understand is that there's a kind of fairly steep barrier to entry with Kubernetes, both in terms of like learning and in terms of cost of like running it. Beyond that, I can't really